Sorry I can't be there in class today. My daughter is sick, so instead you get to watch or listen to a video of my voice and hopefully learn something. Like always, if there are any questions at all, shoot me an email or you can talk to me in class when I'm there on Thursday. So with this slide, the main ideas are elements and compounds are two different things, and we haven't really learned about that yet, but we will. The key, hold on, I'm trying to get my highlighter to work, is that chlorine is one single atom by itself, and sodium is another atom. If they're elements, we'll learn about them. But when they're together, they form salt, or sodium chloride. So separate, it's chlorine and sodium, but together it's considered salt. And then salt traditionally is found in like this crystal format, which is a bunch of them together, and they are held together by their negative and positive charges. Similarly, something else you need to know, oxygen is one single atom. It's this bigger atom. And then we have hydrogen, which is smaller, and when you have two hydrogens and one oxygen, it forms water. So this combination of three is water, but again, separately, it's hydrogen and oxygen. When something dissolves, like our salt in water, what happens is these water molecules will come in. So this is a water molecule. It will come in and it will attach itself to either the sodium or chlorine. And it's actually going to pull, I can't pull both of them, it's going to pull it apart. So the water is going to come in and pull the sodium and chlorine apart. And it's going to take this salt crystal and really separate it into pieces. Again, water molecules come in, and I don't have enough water molecules because I didn't plan this really well, but you can kind of figure out what's happening, and they separate. So each of these, so pretend this chlorine has a water molecule attached, they each have all these water molecules. So what's happening is salt is actually being split apart. So the sodium chlorine atom is being split into different pieces, and they're forming like this mixture, and it should be evenly spaced, but I didn't do a great job of evenly spacing it. Evaporation is truly the opposite. So we have all of these water molecules that are attached to either sodium or chlorine, and this is like if I look at a cup of salt water, all I can really see is the water molecules. But as these water molecules start evaporating, these sodium and chlorine atoms are left alone, and because they have one has a positive and negative charge, they'll actually attach to each other. So that water gets evaporated, that sodium is left, this water gets evaporated, it's left, this water gets evaporated. And you can kind of see it's starting to form this pattern. And what's happening, oops, I went the wrong way. It's reforming the salt crystal. And the reason it's forming the salt crystal, the water is obviously going up into the air, but the sodium and chlorine have these charges still, neither the positive or the negative charges, so they're actually drawn back together. Whoa. Sometimes it doesn't behave with me. So here is my pretty sloppy salt crystal. So you'll notice with the evaporation process, it's reforming salt. So when we were looking at the sea salt, all of the water, the seawater, got evaporated in this the air, and we got left with a pile of salt. The key here, it is not separate Na and Cl. They really attach back together to form those salt crystals. Now, I want you to think about these questions. I'm going to give you a quick little pause. Think about the answer to how do the number of sodium and chlorine atoms compare before and after dissolving? So I'm going to give you a couple seconds to think about that. Hopefully when you thought about it, you would say they are the same. You'll notice my sodium and chlorine never went away. So I had the same before, same after. They just split apart. The same, they just split apart. And then I want you to think about the second question, how do the number of sodium and chlorine atoms compare before and after water evaporated? So we had them all in pieces, they were in pieces, and then they came back together, So really the number stayed the same. And when we start talking about chemical reactions, how chemical reactions change from dissolving and like really the differences. We're going to explore this more. But if you just think about the animation and what happened, nothing went anywhere. The water did evaporate, but the sodium and chlorine, they just separated and came back together to form salt. So I want you to think about this question too. If the number of atoms stays the same, what do you think happens to the mass of the salt before and after dissolved and the water evaporated? So pretend I started with 10 grams of salt. And I know I dissolve it into water, so I now have all these little teeny tiny Na and Cl. How many grams do I still have? And the answer is still 10. So they didn't go anywhere. Again, they just split into little pieces. And then if I evaporate out that water, what do I get left with? Think in your head, guess a number. And again, the answer is 10. So nothing went anywhere. These just came back together, NaCl. So technically, if you take 10 grams of salt and mix it into a cup of water, and then let the water sit there for like a week, you will be left with salt again. So think about this question: is anything new produced when a substance dissolves? Hopefully you answered no. I didn't have new compounds being formed. We still had Na, and we still had Cl, and we still had H2O, but nothing new was being created. And then think about this next follow-up question. Do you think dissolving is a physical or chemical change, and why? So formulate an answer to that question. It is a physical change. And it's a physical change because nothing new is created. New is created. Again, that compound split apart and came back together, but nothing new was created. I started with NaCl, so sodium chloride, which is again salt. It did break apart into Na and Cl, but then it came back together to form NaCl and salt. So nothing new was created. If something new was created, it would be considered a chemical change. Okay, so to wrap all this up, we are still talking about bath bombs. I know it's been a while, but did the bath bomb dissolve? Why or why not? Before all of these dissolving lessons, I would say most people said yes, originally. But think again in our definition of dissolving and what really happened. Hopefully you would say no. Why or why not? Hopefully we realize that like bubbles were created. So that means something new was created. So it wasn't simply dissolving. Okay, so transitioning into our next thing. We've done this notice and wonder protocol before. So I want you to quickly think about the questions. What is it? Why do we do it? And what do we, as in like us as students, really struggle with? So take 10 seconds to think about those questions. Okay, so notice. What is it? Notice are those observations. And again, we want them to be as specific as possible, as detailed as possible. I know we hate writing, but I really want us to do a great job at this. And then wonder are where we come up with those questions. And I know some of us are great at coming up with questions and some of us struggle. This is definitely a work in progress throughout the school year. But really try your best and push your thinking because none of us are really chemistry experts. Why do we do it? It's really the heart of science. All of science is based around our ability to make observations and to develop questions. So I'm really trying to get you to think like scientists. And then what do you struggle with? That would be your personal answer. Some of you might struggle with coming up with questions. Some of you might struggle with like actually writing things down. Some of you might struggle with detailed observations. I just want you to make like a mini goal for yourself. So which of these like do you really struggle with, and try to really put some effort into being better and putting just some thought into it. So what you're going to do today, you're going to look at, I think it's 7 or 8 different ingredients. Most of these ingredients are in the bath bomb, except sugar. Sugar is just really cool, so I added it. And what you're going to do is you're going to look at the name of it, compared to a picture, compared to the chemical formula, compared to like a model of it. So you're pretty much comparing these 4 things for 8 different ingredients. And I want you to come up with a list of things you notice and a list of things you wonder. And so I did water, just to kind of show you what I'm looking for in the detail. I want more than one bullet point. So things that you could notice for water, water has 2 H atoms and 1 O atom. So again, you could notice something about the model, the picture. You could do something about the formula. You could do something about the name. So like, oh, di. Di means 2, so dihydrogen. Maybe that has something to do with it. The oxygen atom is bigger than the hydrogen, so again, I'm looking at this. Color really doesn't matter, but you could say red versus gray, that's fine. The oxygen is in the center between the 2 hydrogens. You could talk about there's a small 2 here, but there's nothing here. And then again, I have a list of questions, and I could have come up with more, but you could talk about the spacing. Why is the number, if you didn't know that H equals hydrogen, that could be a question. What does the H represent? What is hydrogen? What is oxygen? So I want you to really push your thinking, spend some time with it, come up with as many questions as you can. If you feel like you don't have enough room on your piece of paper, you could write on another piece of paper as well. But your goal is to finish this, the worksheet that you were given. All of the ingredient cards are on Google Classroom, and if you don't finish it in class, it is homework. So I'm sorry I can't be there today, and I'm sorry this video is so long. Hopefully you can understand it. Again, you can email me if you have any questions, or ask a friend, or ask the substitute, or ask Mrs. Foley or Miss Henry. But have a great day, and do great work today.